There we go. All right. So just a little bit of a context setting for our research activities. So a lot of you don't know that we actually have the kind of advanced research that we conduct. So part of this is just getting the word out there and giving you a flavor of the types of research areas that we're investigating. We take a different approach to research than some others. We take a very collaborative approach to our research topics. We partner with universities, with other companies, and with government institutions in a collaborative fashion, because we believe that the problems of tomorrow really do require a much more collaborative approach than trying to solve these challenging problems in kind of an isolated, insulated ivory tower. That's an important distinction. Another one is that while we are looking 5 or 10 years ahead in the future and there are a lot of unknowns, we also want to make sure that we're grounded in investing in problem areas that we believe are going to have very real practical applications for our customers and to our business in that time frame. So we try to be pragmatic and collaborative with our approach. And I think, as you'll see in the topics that we'll cover, and this is just going to give you a flavor of our research activities, I think we get a significant amount of value with our activities. Our research activities are global. We have researchers in Australia, in North America, in Europe. Victor is actually based in Europe. He'll introduce himself along with Maria and Steve. Maria is actually based in this office here. But we do try to distribute our activities really across the globe, and that's another aspect of our research activities that I think is unique. We really do try to take a very global approach and view to the work. So without further ado, Steve is going to be our first presenter, and I said this is going to give you just a flavor of our research activities. The brochure that you have, augments what you're going to hear from arguably the 3 smartest people in this room. So without further ado, I'll ask Steve to come up and kick us off.
Thank you, Otto. Thank you, everybody, for your attention. As Otto said, I'll be representing the research that we're doing in security and privacy. So there's a number of different researchers working in this area within our lab, but I'll be talking about collectively our research in that area. Just to introduce myself, I'm Steve Greenspan. My PhD is actually in cognitive psychology. The interesting thing about that is recently, with advances in AI, my background is actually becoming more and more important. We're getting to the point where you can actually think about the same processes in both human brains and in some of our intelligent systems. We're not quite there yet, but it's becoming a reality. So, and in addition, prior to joining CA, I was part of AT&T Bell Labs, part of AT&T Labs, and in all cases, I was doing research on user experience and its connection to privacy, security, now Internet of Things, AI, and cobotics, which you'll hear about momentarily. So to begin this talk, there's 2 things that I wanted to identify. One is everybody is probably familiar with the term GDPR, General Data Protection Regulation. It went into effect last month. It is the regulation that governs the way personal data is used in Europe. But because of the way the law is written, or the regulation is written, it affects almost every business worldwide, and every business that touches any business that's dealing with European data. So it's really an important sea change in privacy law. It's based on a notion of, on a definition of privacy. So in order to talk about GDPR, we have to understand those definitions. That definition is privacy is an issue of control over who sees my data. It's based on the assumption that data is private property, and I, as an owner of that data, get to choose who sees the data, what they do with it, and I can take it back when I want. But GDPR defines the what, and I'll explain that in a moment, but not necessarily the how of how to achieve privacy under that definition of privacy. Some of the things that it says is that we should limit data collection. Only collect the data that you need for your application. That's really different than the big data framework where you collect as much data as possible, even if you don't know what to do with it, even if you don't know what it means. It's the exact opposite. We want to limit who sees the data. So this is an issue of access control. And today you heard a lot about access control in the morning sessions around security, our work in frictionless security and privacy, and moving the concepts of security into the development phase, into the early design phase. We can call that security by design. We also, under GDPR, need to continuously assess how we're doing as a system. Are we maintaining that privacy? Are we guaranteeing that control over the user's data? And lastly, limit processing. There's much more to GDPR than just these four things, but these are the four things I wanted to talk about with you today. Limit processing has a number of different implications, but one of them is that the data should only be used for its stated purpose. That I shouldn't be able to infer things from that data that aren't part of the purpose of the application. And that's really hard, and we'll talk about that. Okay, so how do we do this? First, we want to move it left. You heard about frictionless authentication today, earlier today, but we want to build a larger framework for moving privacy left by doing privacy by design. The name of the project is Privacy and Data Protection for Engineers. It's an EU-funded multi-partner project. So there's a number of different companies working together with us. We have particular roles within this, but one of the things that we're doing is helping to design a risk analysis and decision support capability and framework so that developers understand what they have to do to be GDPR compliant, and that their access to personal data is governed by that compliance. So it's two things. It's one, making sure that developers only see the data they need to, and the application that they create only allows others to see the data that they need to. So both in deployment and development, we're keeping consistency with GDPR. So this is a continuation of work that as you can tell, that work that CA has been doing for many years. The work that we are pretty compliant with GDPR, and in fact entirely compliant with GDPR, both in our practices and our products. But this makes it possible for others to more effectively be compliant. Important in this is the development tools that we're providing don't require that engineers have a deep understanding of GDPR. That means this can be used not only by large corporations, but by small businesses as well, who can't afford a CTO and a team of lawyers and analysts to figure out what GDPR really means under all circumstances. We do it for you. Now I want to turn to access control. So this is an important part of that definition. Who controls who accesses the data, and I want to be able to control that very carefully. So the typical ways of doing it is passwords. Everybody knows that passwords are problematic. You forget them, they get stolen, they get cracked or hacked into. There's other behavioral, there's biometric measures that can be used to help provide multi-factor authentication. But one of the things that people have started to look at is behavioral markers. So looking at what you do, and there's a lot of advantages to this, because if we can figure out what you normally do, even if you're erratic, how you behave, then we don't have to keep asking you, are you really you? We can figure out who you are based on how you act. We can look at your typing patterns and how you move your mouse. We can look at, if it's a mobile phone, we can look at your walking patterns. That's on the client side. On the server side, we can look at what applications you're accessing and how you access and the time of day that you're accessing it. All of this is taken together to create a unique profile. So even if you sometimes go to lunch and sometimes work through lunch, and it's unpredictable which you do when, you have certain behaviors. There's certain ways you type when you're working, and they differ from the way you type when you're not having lunch, right? Because it's hard to eat and type at the same time, but we all do it. We all use our phones and eat at the same time. It's all unique, and we can figure out, if we can figure out what you're doing, we can figure out how you do it and what your unique signature is. In that research, I should say, using these behavioral markers, we were able to get over 95% accurate identification within a large database of users. So we have a nice proof of concept that this works. And what's really nice about continuous authentication is that if you're using a system and walk away and somebody else starts to use it, we can detect that. We can detect that change. If you're purposely letting somebody else use your system, say an application, after you've logged in, we can detect that change, potentially. We could also potentially detect if your intent has changed, if suddenly your behavior starts to reflect the behavior of someone with malicious intent. So insider threat might also be detected. So even though you know your password, we can detect something's not right. Right? We may not know for sure, but we can send signals and start to look at, in more detail, what you're doing. So we just talked about control over who accesses the data, but that's really not sufficient, right? The definition of privacy that we started with, which is control over my data, who sees my data, is not sufficient. And the reason is I can allow somebody to see my data, but that doesn't mean I can control what they do with my data and what they infer from my data. We just, everybody has read about Cambridge Analytica and Facebook. There was no security breach there. Cambridge Analytica didn't decrypt data that they weren't supposed to see. They didn't break into any system. They were given that data by Facebook. There was no security breach. There may have been a terms of service breach, both by Facebook and by Cambridge Analytica, but there was no security breach. This is purely a privacy breach. And it has to do with what Cambridge Analytica could infer from the data they were given. There's another really great story about anonymization. It does not work. That's the basic line here. That's the basic message. And the great example is Australia released the medical billing data for about 3 million people with the hopes that third-party businesses would start to innovate using that data, come up with more efficient ways of dealing with the medical process. And within 3 months, faculty at the University of Melbourne said that they had identified 80% of the people in the data. Now, Australia, the government was very clear. They had anonymized or encrypted all of the personal identifiable information, and without decrypting any of that, they didn't break the encryption. They were able to identify it by linking it to known information about the other people. So 80% were identified. Anonymization doesn't work anymore. In the age of big data, it's not an effective way of maintaining privacy. So how do we do it? Because it's really important to share data. Without sharing data, our economy doesn't work. Every time we talk to each other, every time we log in, every time we interact, we're sharing something about ourselves. And our economy, our social life, all depend on that. It also, for medical researchers, if a medical researcher in China and a medical researcher in Texas want to share data, it's really hard today. They have to find a third party often that is HIPAA compliant, and they can't see each other's data, only the third party can. That really impedes medical research progress. If I want to have a customized user experience, I've got to share data. Banks, if they cooperate with each other and share data, they can create stronger fraud detection models. But you have to do that without violating the privacy of the customers. So how do we do that? What we've been experimenting with is something called differential privacy. It's not something we invented, but it's a method of adding just a little bit of noise to the results that you get from a query so that the results are still scientifically valid, they're still highly generalizable, but it makes it impossible to know whether somebody or not was in that data. And that's because they've changed it. We have a new definition of privacy from this, right? So in addition to that one about controlling who sees my data, here's a second definition. And they're not mutually exclusive. In this definition, the analyst has no way of knowing whether or not a particular person was included in the database. That means that if an analyst is asking a question about the data they get back is the same regardless of whether Otto is in the data or not. So they can't determine from that whether Otto is in the data or not. And they can't make inferences about Otto. So that's really nice. And what we did was we took credit card transaction data from different banks, and we created a deep learning system to model fraud detection, and we got really nice results where we've shown that we can converge on a model or learn a model of data of fraud detection more quickly and as accurately as if we didn't preserve privacy. So we can actually preserve privacy and create a gain in efficiency. And we're going to give that paper in about a month at TrustCom. The point of this research and other research like it that we're doing is that there are ways of protecting, of limiting processing, as we said, and continuously assessing how much privacy is leaking from your database. So to sum up, we're creating technology that helps software engineers continuously assess GDPR compliance, provide continuous control over who sees the data, and prevent data inferences that violate privacy policy. That's the scope of the research around this. There's other research that we're doing in privacy and security as well. We can talk about that later. But now I want to turn the talk over to Maria. I've talked about how to protect data. Maria and Victor will talk about how to use that data to make the world a safer place.
Hi, thank you for being here. Today, I'll have the pleasure of introducing a very interesting topic, which is robotics. Throughout my career, I have always been interested in some aspect of how we as humans interact with technology, how we interact with mobile devices, how we collaborate when people are using different devices, how we understand the information that is presented to us in the user interface. This is a new era of interaction of humans with technology. We are moving from robots that are on factory floors, surrounded by cages, to robots that are going to be sharing not only the environment with us, but they are going to be collaborating with us. They are going to be our partners, not to replace us. They are going to help us do our job better. And this is really an area on robotics that has flourished over the last few years. This is all fueled by AI. How AI is allowing these robots to be intelligent, to understand the environment. The process is slow. I mean, with these robots on the factory floor, they have been there for decades. They have been built to either manage huge machines or to build really delicate components. We know how to create that. What we don't know is how to make them understand what happens when you have a human in the room. We are so unpredictable for these systems. That's why we are really limited now to what we have in terms of robots in the environment. We see the little vacuum around the house. We have the security robots in the shopping malls, going back and forth. Some at the airport, and we have now the drones that can have autonomous behavior. But these advantages of having the AI be able to be processed in the system, in the robot itself, is actually allowing us to bring autonomous vehicles on the road. And we will talk about some of the aspects that are really important beyond the hardware of the design of the robot to make it a cobot, a collaborative robot. So here I'm just showing some of the spectrum of how these robots look like. So you have the traditional robot inside a cage, pre-programmed to do the same repetitive job once and again and again. If you introduce a little bit of the human in this loop, you have robots that can be guided, like the drones that you can buy. You use some device to actually control the movement of the robot, and the robot has some sensors, cameras and others, to give feedback to the human, which is the one making all the decisions. Then the next step is to make the robot a little bit more intelligent. And this is closer to, let's say, the robots that you see at the, some of moving boxes, for example, in Amazon warehouses, of some of the robots that you have in Boston Dynamics, that they know how to walk in the room. They still tell them where to go from here to there, but they make all the decisions of how to avoid obstacles on the way. That's a level of intelligence, of semi-autonomous behavior. Finally, and this is what this research is aiming for, is a robot that is going to have an autonomous behavior, that is going to see what you are doing and is going to make decisions and trying to think of what can it do to help you do your job. So when you ask for cobots and you just Google the term, usually you get information about the hardware, what has to be done to make a robot collaborative. So controlling the way it moves, the force, but we are interested in the aspects that at software level are making this robot safe. What can we do on the software to apply the AI to understand the environment so you are actually avoiding errors? Because when you have a human in the room, if you make an error, it can be deadly. That is what happened with Uber, right? Uber just released information saying that their sensors actually capture a person crossing the road, right? Maybe not the camera, we saw the footage, but the lidar did. But it's this process of gathering information from all the sensors available to the robot and making a decision, understanding what's happening, that failed. So think about the car going on the road. It sees something, the camera sees something in front of it, the lidar also gives the information. The robot needs to decide, is this an obstacle I need to avoid? Is this just a bag floating on the road in front of me? Or is this a person crossing? Do I need to stop? Yeah. So depending on the model that you're applying, you are more likely to fail one side or the other, right? So you can end up with a car that is going to be stopping every 5 seconds because there is something on the road. Or you can end up with a car that made a terrible mistake. So is that, this is the first area of research that we are working on. How are the different AR models that we can apply, how they interact with this kind of errors that we are making. And when you're thinking of cobots, we need to find a balance of what is going to be the best one for different situations. Another aspect with cobot is if we are really going to have a collaborative robot, how are we going to communicate? Right now, with a joystick that allows us to do a few things, some allows you to enter information on a cell phone and will react to it, but a cobot needs to support really more natural ways of communication. So we are trying to see whether it's going to be natural language, sign language, how is that communication going to take place? How simplified we can make that language in order to communicate. The second aspect is, and think of Midas when you're thinking of this, when you say, okay, clean up that mess, and there's, let's say, I spill something next to the door. Then the robot comes, and instead of seeing that only spill on the robot, it looks at the board, and there is a lot of things drawn on the board. For the robot, that could be the mess, and ends up pretty much deleting the whole graph that I have been working on the whole day, right? So what is the mess? A lot of the work that Steve has done throughout his career is going to come to play here. They have been looking at how humans communicate in that. We need to start to look at that in the context of robotics. And finally, when a human needs to intervene, a robot is doing something and we need to intervene, it's very difficult to understand what the robot is doing and why, so we can actually provide a better guideline. And it's that kind of control, understanding what the robot is doing, that is important. And to complicate a little bit more this problem, we have this particular issue that the robots are not really just communicating with us. They are working in an environment that is now an intelligent environment. We have sensors now in intelligent buildings that are giving us extra data that a single robot doesn't have. We need to be able to integrate that with the information that the robot has, and to augment that as part of their understanding. This opens a whole lot of issues in terms of security, right? You could actually change the robot's behavior if you just alter what is happening in the sensors, the information you get in the environment. And that can be dangerous. So the security, privacy, all that information, all those aspects are key on this part. One of the biggest consequences of not introducing this information as part of the system in general is we have seen a lot of errors happen in autonomous systems, especially flights. The flight, once you take off, basically, and it's across Atlantic, there's not much to do for the airplane pilots. What happened in this flight, I don't know if you remember, it's a flight that took off from Brazil to Europe. Suddenly, there was an alarm. Some of the sensors that measure speed outside were not working. The system was completely confused. And the pilots were left trying to understand what was happening with this machine. By the time they figured it out, it was too late. There was no time for them to change it. So it's that kind of separation that is causing issues like this. And this is another area of research in which we are actually making advances now. So now that we are closer to the topic of IT, Victor is going to introduce some of the research that we are doing in this area and some other important aspects.
So thank you very much, Maria. My name is Victor Muntés. I have been with CA Technologies for 7 years. I'm co-leading with my colleagues research around the world, in my case from Barcelona. I did my PhD on optimizing complex queries in relational database management systems funded by IBM. And I had also the privilege to be 8 years lecturing at the university as a professor. So I have this hybrid profile. So continuing with what Maria was saying, let's just jump to the next area, which is how to ensure the new world of IoT. So it is exciting to think the new opportunities that IoT will bring to us. So just think about living in the smart city of the future, riding an autonomous vehicle, or just traveling with Hyperloop. All these ideas, all these visions have something in common. They rely on IoT systems. IoT systems are composed of many different components. You may have actuators, you may have sensors, you may have software that acts as the brains of the system. And one of the big issues is how to ensure that all these systems are trustworthy. And our research is going to focus in particular in this aspect. So therefore, trust is a key aspect here. According to Gartner, through 2022, the #1 barrier for IoT adoption is still going to be security. More than 50% of the security budget in IoT is going to be used for fault remediation, so to solve problems that have already happened in my system instead of using it to protect the system. And we are just talking about security here, but in reality, we were saying that those systems need to be trustworthy, and that includes also privacy. We just saw GDPR coming into force 10 days ago with a lot of challenges for industry. Safety, because these systems are bringing the physical world and the digital world together, reliability, resilience, etc. So digital presence is becoming pervasive, and that brings a lot of unintended consequences. How to control these unintended consequences is our focus. So there is no complete DevOps support for the creation of trustworthy smart IoT systems. That means that continuous delivery, operation of these systems becomes very complex because of many different factors, because you have a massive number of devices that are heterogeneous, because you rely on networks that are unreliable, because the topology of your system may be changing all the time. So the big question is, how do I control all this complexity around IoT? How do I control the new vulnerabilities that I'm creating in an IoT system? How do I control the risks that I have to take into account, and how do I mitigate those risks? I want to make these devices more intelligent, so how do I embed artificial intelligence into those devices? How do I test these applications? Typically, by the time that I'm developing a software, an IoT system, software for IoT system, I do not have access to the infrastructure. So how do I make sure that my software is working the right way? Or even more, how do I operate those systems? How do I make intelligent systems that are able to understand what's going on in my systems, that are able to predict what's going to happen, and are able to prescribe what are the best actions in order to control them? So let's talk a little bit about risk. I don't know if you were aware that it is possible, for instance, to send secret audio instructions that are undetectable to the human ear, that can activate Amazon's Alexa, that can activate Apple Siri or Google Assistants, just making them, for instance, do actions like connecting to a URL or buying something without you even noticing it. Were you aware that, for instance, it is possible to hack your smartwatch in such a way that with the motion sensors they can see what you are typing in your keyboard and get, for instance, your passwords? So all these new devices bring new vulnerabilities that were unheard of. And the problem of creating an IoT system is that it's not only one device, it's the combination of all these devices together. So how do you control the risks that all these devices in combination generate? So we have already created pilots, new tools, novel technology in order to manage risk using agile methodologies. So we call it agile risk management. We are trying to get research in order to see how we adapt this into the IoT world in such a way that you can detect those vulnerabilities. And not only that, whenever you detect one of these problems in your system, probably it's too late, and this is going to generate a major refactoring in your application, in the architecture of your application. So how do you measure the risk on your software development? How do you connect back operations to development? We were talking about making objects more intelligent, and we believe that technology is already prepared in order to make these devices more intelligent. Just think about the idea of introducing artificial intelligence into a microcontroller. All of a sudden, you can make devices cheaper, you can make them lower power, and you can make them smaller. And that means that probably you can reduce the bandwidth because they will not be able to, they will not need to send information because they can do more things locally. That reduces latency because they don't need to communicate, and that also means that you're improving privacy because you don't need to send data over the network. So basically what we are doing from our research team is trying to see how we can map different inference models created by deep learning into these devices. And not only mapping them for the first time, but as the system keeps evolving, reorchestrate the artificial intelligence in my IoT system. And again, we're talking about artificial intelligence. That means training very complex models. This may take weeks or even months. How do we match this with the agile world, where you have shorter sprints, 2-3 weeks, typically driven by short-term requirements by your customers? How do you match the two worlds? That's also something we are trying to investigate. Continuous delivery. I was talking about testing at the beginning. Typically, as I was saying, when you are developing an application, you don't have access to the infrastructure in an IoT system. That means that you would need to understand how devices in that ecosystem are going to work, but also how do they communicate to each other? What type of protocols they use in order to talk to each other? So we have invented mechanisms in order to discover those protocols that the different components use in order to talk to each other. And for instance, one of our findings was that by applying genome sequencing algorithms, and we use that in order to discover byte-level patterns, we were able to understand what were these protocols and then emulate the behavior of the devices in such a way that we could virtualize them, replicate them, and then create an environment for testing the application. And this without requiring any expert knowledge. And not only that, one of the big issues of artificial intelligence is that whenever you have a model that is learned automatically by a system, typically we know that accuracy may be good, but there are always corner cases where accuracy is not so good. So we are trying to investigate in models that are editable by humans in such a way that you can correct models once the machine has already learned them. And this is just to emulate devices, but we're also trying to simulate the IoT systems. And it's not only about simulating devices, it's also about simulating higher level patterns. So for instance, a cyber attack that is affecting several components in my system, how am I going to simulate that, and how is this going to affect my application? So all in all, both for simulation and emulation, we are taking into account these inter-device dependencies that are always present in IoT systems, and we are trying to drive part of the technology that another of the accelerator projects is developing, which is nothings.io in this area. So finally, how do we operate IoT systems? How do we bring no-ops into IoT? There is a gap between what a human expert can bring in terms of operating a system based on his or her expertise, and what an automated system today can do, which is typically based on system knowledge. So how do we fill that gap is one of the big questions that we are trying to solve. For that, we have devised different types of algorithms. So we are trying to use the graph expressiveness in order to capture information about the topology of the system, because we feel that this is one of the ideas, the concepts that is not being used enough. And we are trying to connect that with domain knowledge in such a way that we are aiming at generating the next generation of controlling systems, for instance, for root cause analysis in IoT environments. And we are also using deep learning techniques in order to understand in real time what's going on in the system, being able to predict and prescribe actions in order to mitigate whatever is happening in the system. Let me just jump now to the last area, which is raising baby artificial intelligence and how do we create ethical software. I'm sure that many of you have children, and I'm sure that you agree with me that education is challenging. Typically, you would like your kids to do what you say, but they end up doing what you do. And that's exactly the same, it happens the same with artificial intelligence. You would like your artificial intelligence-based system to do what the system is intended to do, but at the end, they end up doing what the data that they are consuming tell us to do. So basically, they are learning from the past, which is basically explaining what you did in the past. So let me just put some examples. Google Translate has been reported to be sexist very recently. Just an example, if you get a gender-neutral language like Turkish and you translate into English, you may get sentences like, he is an engineer or she is a nurse, and there was no gender information in the original sentences. Yet, so there is a fundamental question here, which is, how do I get rid of the bias that I have in my input data so that it does not generate discrimination through my artificial intelligence? Second, we were talking, there was another example with Amazon that was excluding minority neighborhoods from its Prime service, the same-day delivery service. And when they were trying to understand why, of course, they realized that they were not using any information such as the color of your skin. They were using information such as where was the closest center for delivering packages, whether there was a transportation system 24/7, including Sundays, or the number of customers that you had in that area. But all these variables were acting as proxies to hidden variables that had social ethical connotations, and that was one of the problems. So another fundamental question is, how does a company know that their artificial intelligence is generating some kind of discrimination if the company may not even have these hidden variables? And I'm not saying that Amazon should have information about the color of our skin, but this is a fundamental question and an obstacle in order to make this a reality. And yet another example, North Point's had software called Compass, which was basically trying to predict recidivism for people that were awaiting for trial. So we had a court, a judge, the judge needed to decide if they would allow them to go on bail while they were awaiting for trial, or they would keep them in prison, and they were using, for instance, this software to make the decision. So there was a group of researchers that showed that for those people that were actually not reoffending, black people had a lower, let's say, a lower probability of getting a higher risk by this software than white people. But then North Point proved mathematically that for every level of risk of their function, your probability to get the same score or a mean score was exactly the same no matter what was your color. And there is another fundamental question here, which is that there is no single definition of fairness. There are many definitions of fairness. So defining mathematically what fairness means, it's also a big problem. But this is already hitting the real world. So you see governments spotting ethical issues as one of the main obstacles for creating and adopting artificial intelligence. GDPR came into force 10 days ago, and it explicitly says that it is prohibited to generate any type of discrimination through automatic decision systems. But this clashes frontally with another reality, which is complexity. This is a statement by Mark Zuckerberg, where he said that it is more difficult to find a nipple in an image than that automatically detecting hate speech. So the problem is very, very, very complex. And how to match these two requirements, one from society and the other one from science, which is complexity, it's a big issue. Let me just come to another example. There was a group of researchers, of scientists, that took a real data set. They distributed this data set among more than 60 different researchers, and they made them a question, which is, do soccer referees give more red cards to dark-skinned players than light-skinned ones? And the interesting result of this experiment is that 20 teams, they just grouped all the researchers and data scientists in small teams. 20 of these teams concluded that dark-skinned players were getting more red cards than the others, while another 10 or 9 teams concluded that there was no statistical correlation between the two variables. And this brings to light another complexity in this problem, which is that even when you have very skilled data scientists and researchers that were using a lot of different types of techniques in order to do these experiments, they make choices while they are analyzing the problem that can significantly change the final result and the final conclusion of your analysis. So again, deciding what is bias and what is fairness becomes very complex. So that's why we are doing research. We believe that artificial intelligence is going to bring a lot of benefits. We also believe that ethical issues may avoid artificial intelligence deployments. And then the question is, okay, can we remove bias from artificial intelligence? Or even more, think about new vector attacks, like someone trying to poison your data in order to bias your models and basically damage your reputation. Can we avoid this type of attacks? So our research is trying to create a digital representation of all these social, ethical, legal constraints. We're also talking a lot about artificial intelligence localization. So it's not that the social rules change from one region to another region, from one country to another country. The ethical and social rules may also change. So how do we manage this complexity? And finally, how do we create a system that is able to monitor AI bias continuously and autonomously? So that's what we are trying to do. We are trying to create a better world. In this particular case, we believe that that's through ensuring fairness in those decisions that are made by artificial intelligence. We believe that human rights and fairness, it is central. It's a pillar aspect. It's a pillar for enabling the real use of artificial intelligence. Of course, it is our responsibility to drive technology, and that's why CA Technologies is investigating in the area of artificial intelligence governance. So thank you very much.
So that was just a sampling of some of our research activities, and as you can see, this is not science fiction. You can absolutely see that these are complex challenges and some very interesting areas that will absolutely impact us in the future. It's just a question of when. So with that, we have a little over 10 minutes to answer some questions. So maybe I can have research and accelerator folks come up, and we're happy to answer whatever questions you may have.
Yeah, I'll take this. This is for Steve, actually. You were talking about gathering user behaviors as a way of confirming somebody's identity. But it struck me some of those user behaviors we're collecting were actually invading the user's privacy themselves.
Right.
So have you sort of worked through that problem?
Yeah, so thank you for your question. And it's a great question. So if you notice, there were some server-side collections and client-side. And you're referring to the client-side selections.
Primarily, yeah. But theoretically, the server side.
Right. So in both cases, there are privacy concerns, but especially in the client side, right? It's your behavior, it's what you do during the day, it's how you move and so forth when you have lunch. We can apply what I talked about later in differential privacy to exactly that problem, so that all of the computation, all of the authentication is done on the device, but we're sending certain parameters back that verify that it's you. So by using differential, it can be, I'm sorry, go on.
It still makes me uncomfortable.
Okay, and that's fair. That's fair. I mean, it's.
If you're taking a picture of me naked, but nobody sees the picture, is it an invasion of my privacy, or because nobody can see it, then maybe it's okay?
Remember, under GDPR, we still have to ask for your assent, right?
Yeah.
So you still have to say yes. You're willing to share that kind of data with us under those guidelines. Don't share that kind of data. Right. Exactly. And so you get to decide. And we're strongly, we strongly back GDPR, that it should be up to you what gets shared and what's not.
Andrew, one of the things about Waffle that you didn't mention, and I wonder if you've studied it or if Waffle addresses it, developers and flow. I've read that developers need 45 minutes to get into a flow mode. Is that something that Waffle is designed to help?
Yeah, so
Or help prevention from getting out of flow?
Mm-hmm.
yeah, so if you think about like what's taking developers out of flow, and in today's world it's even harder, right? If we're in Slack and everyone's pinging us to Slack, so a lot of it's just working agreements with their team, but Waffle is meant to work in a way that we're automating things behind the scenes, so there's fewer reasons someone has to actually go and interrupt you. Yep.
As a whole, do you think Silicon Valley is doing enough to actually reassure the outside world about some of the things you talked about just now, really? Because, I mean, personally, having seen the guy speak, do you think that, a robot could do the job, Captain Sully did by landing the plane in the Hudson?
Mm-hmm.
I mean, the public are concerned about these issues. Do you think Silicon Valley as a whole is doing enough to actually reassure them?
I'm from Barcelona.
So probably not, and there's there's a lot of mystery around these technologies and their practical applications. And anything that's mysterious is going to be obviously subject to distrust. So part of what we're certainly trying to do, and I think needs to be a larger technology community effort, is to demystify the technologies and their implications. I mean, I think Steve's presentation was a fantastic example of demystifying and making concrete in non-technical terms what GDPR privacy really means and how to address it going forward. So I think there's a lot more that can be done to explain some of this future-facing technology and the issues around it in very clear practical, pragmatic terms.
But these are also not new problems. We've always had an issue with technology at some level, right? If we're talking even 1,000 years ago, and horses, right? How do they behave? How do they behave differently? We've had to accommodate that and learn that over time. And the same thing is happening here. We're going to have to be. We have a lot of research that needs to be done. We have to be very careful about how we figure this out. Everybody in this room is part of the solution. Every company in this area is part of the solution. It's not something that CA can do on its own. Everybody needs to work together to really make this effective and to figure out where the limitations are. In Victor's talk on AI and ethics, this is not an easy question. Determining what's fair and when is really hard, and everybody needs to be part of that discussion. So in answer to your question, I would say yes, it's not a question of whether Silicon Valley is aware of it or not. It's a question of how we work together to really solve these problems, or at least make good progress, and it's going to take time.
And there is also, there is also a trend for more and more companies to understand that converging social needs with business makes more business. Mm-hmm. And I think that there is an evolution in this sense, and yeah, artificial intelligence ethics is one of those areas where things are going to converge.
This is a question any and all of you can answer, and that is, approximately as a percentage of time, work time, do you spend trying to find out what is going on elsewhere in the world, in the industries that you're involved with, right? So specifically, you have product areas and pain points that you are addressing, and you are doing a little further out as to these are issues which are coming or are here, solutions are somewhere else down the road because they're very complex, mm-hmm. et cetera, et cetera. So I'm just wondering approximately what kind of, do you spend 10% of your time generally trying to see what else is going on by your peers, competitors, whatever in the industry, 20%, 15, 50? Just out of curiosity.
It's a difficult question to answer. First of all, it's not only our competitors. We are very well connected with the scientific community, so we spend a lot of time going to scientific conferences, discussing with universities, etc. I guess that would change from one to another. Probably we are easily spending 30 to 50% in understanding what's going on in the world, because we need to be connected to reality, trying to understand the technology trends and trying to see where we are going to be in 5 to 10 years from now.
Yeah, I would agree. And in addition, I think we try to have conversations with a lot of people about what they're seeing. So it's not just us looking for information like in papers or something. It's there's a whole ecosystem or a whole group of
trying
people.
to find out.
Yeah, that's right. And we share
what some of the
right.
issues and challenges and
exactly.
opportunities are.
Right. Yeah.
Specifically because you're more product oriented.
Yeah, I mean, I think that monitoring these ephemeral world is not a solved problem. I think that like that's one of the best parts about my job is like whether I'm at conferences or interviewing customers, I'm learning more about the problem in day out, right? And so that is the constant iterative product cycle that I'm going with talking to the customers. And so me personally, I may spend 40–50% of my time working with customers in one way or another, and that very much is research that's coming into our product and we're learning through as we're going through, and that's one of the really key values of the accelerator we're trying to push forward.
I would probably say we spend less time actually thinking about competitors and more time thinking about our customers. We will always be following if we just look at what our competitors are doing. And usually we learn way more about our problem if we just focus on the customers. It's not just us either. Like sure, we're building new businesses, but we say that everyone is doing innovation in our company. Yeah, we might be doing more disruptive type of innovation, but if we don't disrupt ourselves, someone else is going to do it. So it's everyone's job in this company to listen to our customers to figure out where we should go next.
The common thread is a lot of time spent looking at and not getting stuck in a bubble.
This one's actually for Andrew. You're positioning Waffle as a development tool, and it struck me that a lot of the tasks you're helping with aren't just traditional development tasks. It could be testing, or it could be deployment or security. So it's really sort of broader than just a development tool. Would you agree with that, or did I miss something?
So throughout today, I've heard people say like, hey, like Agile isn't just making waterfall systems a lot faster and smaller. It's actually like every piece of the development process happens over and over again, whether it's development or planning or security. So when we think about like developers doing work, it's no longer just the build phase. It's everything from planning all the way to out to production. So it's easy to talk about developers, but it's really like the whole process of building products. Probably the future that's exciting that we haven't really built yet is how to take that feedback about like what you expect to happen, and then measuring that all the way through the system to figure out where we right or not, whether it's tracking performance changes based on what you shipped, or measuring what's this actually used and are we validating the problem that we thought we were solving. So I think it only gets bigger too. It's not just what we're doing today.
Yeah, so it's a great example of a holistic software lifecycle tool that isn't specific to any particular phase. And I think that's a great model for really the industry, for CA and the industry, is you don't just want to build development tools and testing tools and security tools and just saying, well, we're going to integrate them and it's going to be holistic, hoo boy, but rather building it holistically from the beginning.
Yeah, exactly.
And, so it's a great model.
Thank you.
You had a question?
Yeah, assuming the ethical and human rights questions are answered, when do you think AI would achieve human intelligence?
You mean Terminator?
We have to build an AI system for that.
A true general AI system.
So there have been a lot of work on general intelligence. I think that the whole scientific community agrees that this is a very long-term research. I wouldn't expect to see a really intelligent system similar to a human in the next decades. But that's because it's a very long path to get there, and in the middle there are a lot of milestones that will bring a lot of new opportunities, and that's what we are exploring.
So our jobs are all safe for now.
Yes, yes. That's why we are just...
Even in the area of robotics, when it comes to building AI and models for robotics, there is a big push for open source, but that's because there's very little overlap. They are not competing in open source. Whatever they do for this robot and for this system, it doesn't translate easily. So that now that we have all these safety issues coming to the surface, the whole community is kind of pushing towards trying to work on common, let's say, safety measures, models that can move from one side to the other. But they agree too. It's a question of decades. It's not going to be something that is going to happen in the near future.
And maybe one more short question to wrap up, if anyone has one.
Andrew, just to know if the acquisition of GitHub will have an impact on your business and how you view this move.
Yeah, I was expecting that question earlier. Microsoft has actually turned into a really amazing company in the last couple of years to focus on developers. For example, VS Code is the most contributed to project on GitHub. Also huge contributors to Kubernetes. The person who will be running GitHub was the founder of a mobile open source framework who's very well respected in the industry. So in general, Microsoft will be a very good thing for GitHub and for open source and for all GitHub's customers. For Waffle, I think it's really compelling that we'll be able to reach more enterprises. GitHub has adoption across like 50% of the Fortune 500. I think that will expand with Microsoft support. So Waffle starting with GitHub, that's really encouraging to us. At the same time, we see teams inside large enterprises, they use many tools. They're asked to log in many different places to update status. So there's a huge opportunity to support a lot of different ecosystems that developers have to plan to try to automate the way they work. So yeah, I think Microsoft will be cool. It'll take a while to see how that plays out. I don't think they're going to mess it up for a long time. I'm excited.
So with that, I want to thank our presenters and thank you for being a great audience.
We have about 10 minutes before we start the one-on-ones, which will take place on